Alright guys, time for another video. So in class we've been talking about finding the equation of a line that's parallel to another line that goes through a specific point. And that's what this little video tutorial is going to be about. We're going to find the equation of a line parallel to another line that goes through a specific point. So quickly, let's pick a line and a point. Well, let's say that we start out with the line y equals 2x plus 1. And we want to make a line that's parallel to that passes through the point 3, 5. So first thing, we can sketch this out if we want, and we'll go ahead and do that real quick. It'll only take a moment. We draw our axes, or our coordinate plane, and we make ourselves some marks so that we know how to go by our numbers here. 1, 2, 3. And again, this is just a rough sketch. Doesn't have to be too accurate. To graph this line, and we'll do it in blue so that it stays the same color, 2x plus 1. Well, we know the y-intercept of this line is 1, so we'll go to 0, 1 and place a point. Now, the slope is 2, and we know the slope really represents the rise over the run. So we'll rise up 2, we'll run over 1, and we'll put another dot. Now that we have those 2 points, we can connect those to make a line. And this quick line here, that's the line y equals 2x plus 1. Now in orange, we'll put our point, 3, 5. If we come over 3, up 5, we'll put a point right here. And that represents this place. So again, what we're trying to do is find a line that's parallel to this line and passes through this point. Now, it's not that big of a process because we know some things. For one, we know that the equation of our new line, which we'll keep this in orange so we can keep them separate, it's going to have the same slope as this line. And how do we know it's going to have the same slope? Well, we discussed that any two lines that are parallel must have the same slope. So the way we can start out is by saying that our new line, y, is equal to 2x plus some y-intercept. I think we can all agree that it has a y-intercept. In fact, it looks like it's going to be somewhere around here. We just don't know what it is yet. Well, you may be wondering, how are we going to find out? And the answer to that is the point that we're given. The point has an x and y coordinate, and we'll label them as such. That x and y coordinate are going to be put into our equation. That's going to let us solve for our y-intercept, or b, of our new line. So if we substitute those in, we'll say 5 is equal to 2, since that's our slope, times the x value, and the x value is 3, plus the y-intercepts that we're looking for. Now, we can all solve this. It's just a regular two-step equation. Bring down your 5. 2 times 3 is 6. And then we'll bring down our y-intercept. Well, only one more thing to do. Subtract 6 from each side. When we do that, these 6's will disappear. Just a property of our algebra. And we'll find that b is equal to 5 minus 6, or -1. Okay, well that's great. We have our y-intercept now. We have our slope. So we can say, or we can state the equation of our line. In fact, we'll do that over here. The equation of our line, and the way we're going to write this is y equals our slope, which is 2, times x, plus our y-intercept. And since our y-intercept is -1, the equation of our line will be y equals 2x minus 1. And that's all there is to it, really. It's not that long of a process. So if we want to show this, we'll put another point that's on our line. We have our y-intercept, -1. So let's come down here to -1 and put a point. If we connect these, I think you'll see that this line is in fact parallel to our blue line, or at least somewhat parallel. Let me draw my line a little better. And of course, if you're working this out on graph paper, it will look a little better, but I think you can see that if we would draw this out correctly, those would be parallel. And that's the end of our video. Check out the one where we work out the line perpendicular to another line.